Think about it. Diesel engines, they're kind of the unsung heroes of our modern world, right? They're in the trucks that bring your packages, the tractors on our farms, the machinery in our factories. They are, quite literally, everywhere.
But all that power, it comes at a cost, doesn't it? A big environmental cost. We're talking serious air pollution, greenhouse gases. It's a huge challenge we're all facing.
So, what if the answer wasn't to scrap all these engines or to bolt on some complicated new filter? What if we could clean them up from the inside just by changing what we put in the tank? Well, that's exactly what some researchers are looking into.
All right, so today we're diving deep into some really fascinating research that's all about engineering a cleaner, more eco-friendly diesel fuel.
Here's the plan. First, we'll meet the researcher and get a grip on the problem he's trying to solve. Then, we'll look at how they designed this new fuel blend and, of course, the results. After that, we'll zoom out to see the fuel's entire life cycle impact. And finally, we'll figure out what this all means for the real world.
Okay, so first things first, let's talk about the researcher behind this study and the really tricky problem he was facing.
The person leading this charge is Dr. Mahmoud Karimi from Eric University. And get this, he's not just any scientist. Stanford University actually named him one of the top 2% of scientists in the world in 2023. His whole background is in stuff like sustainable bioenergy and using AI for modeling. And something we're going to talk about a lot, life cycle assessments. So yeah, he's the perfect guy for the job. And the paper they published really gets to the heart of a classic engineering problem. How in the world do you make diesel cleaner without losing all that power that makes it so useful in the first place? So this is where it gets really tricky. You might be thinking, hey, don't we already have biofuels? And yeah, we do. But they have this dilemma. On one hand, you've got biodiesel. It's great for cutting down on that black smoke you see, but there's a catch. It actually pumps out more nitrogen oxides, or NOx, which is nasty stuff. Then you've got ethanol. It's cleaner, for sure, but it just doesn't have the same punch. It's less energy dense, so you lose power. See the problem? It feels like you're stuck between a rock and a hard place. Can you get the good stuff from both without the bad? So how do you even begin to solve that puzzle? Well, it all started with picking the right ingredient. The team decided to create what's called a ternary blend. Fancy word, but it just means a mix of three things. You've got your regular fossil diesel as the base. Then they added two biofuels. The biodiesel comes from algae that you can't eat, and the ethanol, that's made from molasses, which is basically just a waste product from sugar production. And that's a really smart move. You know, it completely avoids that whole food versus fuel debate. And they didn't just guess. Their method was super scientific. First, they ran a whole bunch of different blends through a totally standard, off-the-shelf diesel engine. No tricks. Then, they fed all that data into some pretty sophisticated computer models to see how everything was interacting. But step 3, that's where the real magic happens. They used a special algorithm, a desirability function, to basically ask the computer, okay, find us the one perfect blend that gives us the best of everything. And finally, and this part is so important, they didn't just look at the exhaust, they did a full life cycle assessment to see the total environmental picture. All right, the moment of truth. After all that work, all that modeling, did they find the perfect blend? Let's check out the results. And here it is, the winner. They call it B12E3D85. Now that sounds super technical, but it's just a recipe. 12% biodiesel, 3% ethanol, and 85% good old diesel. This is the scientifically proven sweet spot. So how did it do? Well, the results are pretty stunning. First up, carbon monoxide. This new blend cut CO emissions by an incredible 72% compared to regular diesel. That's a huge drop. Next, unburned hydrocarbons. Basically, wasted fuel that turns into pollution. The new blend cut those by 65%. I mean, that's just a way more efficient burn. And what about that thick black smoke you sometimes see billowing out of trucks? This blend cut that by 57%. So right off the bat, we're looking at a fuel that is way, way cleaner on 3 of the big pollutants. But, you know, science isn't about finding perfect magic bullets. It's about being honest about the trade-offs. And there was one. Remember how biodiesel can increase NOx? Well, this blend did see a 14% bump in NOx emissions. But, and this is a really big but, that's still clean enough to meet the super strict Euro 6 emission standards. It's a compromise, but a very calculated one.
Okay, so what about the other half of the problem, the power? Remember how ethanol can make an engine feel weaker? Well, this might be the most incredible part of the whole study. This new blend, it kept 97% of the power of pure diesel. Let that sink in. All those emission cuts with barely any loss in performance. That's a huge win.
But wait, there's more. Because what comes out of the tailpipe is only part of the story, right? To really know if a fuel is green, you have to zoom out and look at the whole picture. Yeah, the researchers themselves point this out in the paper. Just looking at emissions can be a bit of a trap. You've got to think about everything that came before, growing the crops, producing the fuel, transporting it. And that's exactly what that life cycle assessment, or LCA, is for.
And this is where things get complicated and honestly really interesting. If you look at the whole life cycle, the new blend actually has a slightly higher global warming impact and a bit of a higher toxicity impact, mostly from the farming side of things. But look at that second line down, fossil fuel depletion. This right here is the big win from a big picture perspective. To get the same amount of energy, this new fuel uses 13% less fossil fuel overall. We're talking about a real, measurable reduction in how much we're digging up and burning finite resources. That's a huge step in the right direction.
Okay, so let's put all the pieces together. What's the bottom line here? What's the big takeaway?
Well, the verdict on this B12E3D85 blend is that it's a really smart, practical solution. It's what you call a drop-in fuel. You can pour it into existing diesel engines today with zero modifications. It delivers huge cuts in pollution while keeping almost all of its power. And it helps us use less fossil fuel overall. Now, is it a perfect, magical solution that solves everything? No. But it's an incredible transitional fuel. It's a real, practical step we can take right now to clean up things like trucking and farming while we work on the next generation of technology.
And it kind of leaves you with a big question, doesn't it? When it comes to something as complicated as energy, is the future really about finding one single perfect solution? Or is it about mastering the art of the intelligent compromise, of finding those clever trade-offs that move us forward one smart step at a time?